I believe that when you use your computer and mobile phone, you will sometimes encounter a stuttering phenomenon. Moreover, the longer the machine is used, the more frequent the stuttering will occur, and it may be time to change the hardware. But is the machine stuck really just because of the hardware? Isn't it really caused by the slow calculation speed? Today we are going to talk about the design ideas to avoid stuttering in software development. When we log in, a verification code will pop up. In fact, this dynamic process must be completed within about 16.7 milliseconds. When the mouse clicks on the button, it will trigger an event signal which will run along a predetermined calculation track. That is the program execution flow. After the execution, the processed information is displayed on the screen. So why does it need to be completed in such a short time? Because when the user makes an action, it is hoped that the software will react immediately. That is, it is completed in close 0 seconds. However, the screen's refresh rate is generally 60 times per second. In other words, the software only needs to complete the calculation before the next screen refresh. However, what happens is if you exceed it, it will be stuck. So, stuttering does not mean that the speed is slow, but the reaction is slow and blocked. However, a careful friend may have discovered the problem isn't the slow response caused by the slow speed. To be precise, the stuttering is indeed partly caused by slow calculations, but this reason may not account for a large proportion at all. First of all, let's see what hardware will be involved in such a simple operation just now. First of all, it is the CPU that performs calculations, and its calculation unit is nanoseconds. Then, memory is needed as temporary storage, which is in the microsecond range, and then you need to read and write files to the hard disk, which is milliseconds. Finally, it needs to exchange data with the server, and this is close to the second level. 1 second is equal to 1000 milliseconds, equal to 1 million microseconds, and equal to 10 nanoseconds to the ninth power. Therefore, the impact of slow CPU calculation tends to be small. Most of the stuttering is caused by hard disk reading and writing files and network transmission. How do you reduce the waiting time? Sometimes the computer freezes. Not only the screen does not respond, but the mouse can't move. This is a blockage at the operating system level, the worst. There is also a kind of just a certain software has a freeze, and turning it off will not affect other applications. That is an application level freeze. The situation seems to be getting better. Is there a better situation? Yes. In fact, partial loading is a kind of lag. However, the range of this kind of lag is very small, and users are also told to wait patiently here. Therefore, we only need to ensure that the lag range is as small as possible. Generally speaking, the program flow of software is synchronous. That is, it is executed one after another until all tasks are completed. But some are fast and some are slow. If we bypass the slower part from the synchronous execution flow, there is no need to wait. Let's go back to the picture just now. When sending the information to the CPU calculation, it also sends a network request to the server. Then there is no need to wait for network reply. Render the result directly to the screen. Plus a loading icon. You can do other things happily. Wait until the server replies and then render the result to the screen again. This is synchronous mechanism. Finally, let's look at an example. There are multiple dynamic images. When we load the next animation, If it is a synchronization mechanism, all of them will freeze while waiting. But if it is loaded asynchronously, there will be no lag.